back to another episode of the Future Cities podcast. I'm your host, Stephen Elser. This month we'll be talking with a UREX SRN scientist about a recent publication called Failsafe and SafetoFail Adaptation, Decision Making for Urban Flooding Under Climate Change. The paper was published just about a year ago in the journal Climatic Change. We'll be talking quite a bit about infrastructure today, so if you'd like some extra background about some of the topics in today's discussion, you can go back and listen to our previous episode entitled Resilience in Infrastructure. Without further ado, let's get to our guest. Joining us today is Yong Kim, who is a postdoctoral researcher at Arizona State University. Welcome, Yong. Thanks for joining us.
Hi, Stephen. Thank you for inviting me for a podcast episode.
Yeah, of course. Now, before we jump in, I'd just like to give the listeners a chance to get to know you a little bit more. Could you tell us a little bit about your background, what your general research interests are, why do you study this, how did you get here?
So, hello everyone. My name is Yong Kim. As Stephen introduced, I'm a postdoc researcher with the UREX SRN, and I am right now focusing on theory comparisons of climate change adaptation researches. And to introduce, to start with a broader research interest of mine, that I'm very much interested in implementing scientific solutions for tackling global challenges like adverse impacts coming from climate change, urbanization, and natural resource management. And I want to implement these scientific solutions with actionable policies towards long-term solutions. The reason why I'm really focused on long-term solutions is that I think near-term solutions can be possible with innovative technologies and engineering practices. But however, long-term solutions are also require sound policy that supports societal goals like educating vulnerable populations and suggesting cultural-based strategies to sustain the future generations. So that's kind of my broad research question related to sustainability. To introduce my background a little bit, I am also a recent graduate of School of Sustainability at Arizona State University. It's a very transdisciplinary program that encourages students to work towards solutions across diverse disciplines. And before that, I have a background from my bachelor's and master's degree in civil and environmental engineering. So while I was working with UREX SRN, I was introduced by this concept of SETS system, social, ecological, and technological systems, to deal with climate change adaptation and towards climate change adaptation. And then because of my civil engineering background, I quickly got into think about what's the role of infrastructure in this changing environment. And then when we think about infrastructure, infrastructures are designed or built environment or built systems that are expensive to create and hard to change. And so thus, they are usually long-standing, and they have substantial influence on the functioning on human and natural systems. Yeah. So when we think about these characteristics of built environments, namely infrastructure, it also provides guidance to humans and ecosystem activities, but it also at the same time consumes lots of resources. But also, ironically, at the same time, it makes a lot of resources available to humans and ecosystems. So I think infrastructure is very ubiquitous system in the global society right now. So that's how I got into the topic of infrastructure, and I really become interested about what's the new role, what's the changing role of infrastructure going forward with the future climate and environments.
Well, that's all sounds really interesting and really important. So looking forward to chatting with you a bit more and hearing more specifics about the kinds of things that you've been doing. So before, I guess right off the bat, to get into the paper, right there in the title are a couple of terms that I want to address, failsafe and SafetoFail. I think that most people listening probably have heard the term failsafe before, but I imagine SafetoFail might be new to a lot of people. Could you just tell us what these two terms mean?
Okay, so as you already all noticed that I am promoting for SafetoFail system, but I'm gonna start explaining what the Failsafe system first because the title says Failsafe to SafetoFail. So traditionally, many infrastructure systems are designed as fail-safe. They are designed to prevent any level of failure up to a certain risk threshold based on risk calculation. Thus, when infrastructure failure does occur, the consequences to human life or properties and other infrastructure systems can be enormous and catastrophic because these consequences are not included in the risk calculation.
Yeah.
So risk-based fail-safe approaches are often contingent on the statistical analysis of identified risk, the specific risk, but often do not account for uncertainties associated with these risk calculations. And also with the future climate change and like complex and interconnected infrastructure systems that exist in the urban area, and also, most importantly, unpredictable human behavior.
Yeah.
And like the decision making of the human system. So as a result, when these failed systems are disrupted, the consequences can be catastrophic, and especially when they are confronted with a low probability and high impact extreme weather events.
Yeah.
So, but on the other end, a SafetoFail approach
Yeah.
still manages the risk, but also recognizes consequences of infrastructure failure that may arise from the uncertainties within the risk calculation. And it also focuses on strategies that do not necessarily compromise the entire urban system upon failure.
Yeah.
So, SafetoFail approach, it rather than focusing exclusively on reducing the probability of a certain failure or the risk occurring, but it resonates with the resilience engineering strategies by acknowledging the wide range of possible mechanisms and consequences of infrastructure failure beyond the calculated risk and the design safety threshold.
Yeah.
So I guess maybe a good example of kind of comparing this fail-safe
Yeah,
and
that'd be great.
safe-to-fail approach will be the project that has been done in Netherlands called Room for the River. So this example, I like to take it to explain fail-safe and safe-to-fail because it actually moved from fail-safe approach to safe-to-fail approach to deal with the chronic flooding problems in Netherlands.
Cool.
So as many people would familiar with the situation of Netherlands, they have a chronic problem of flooding because the sea level rise and heavy precipitations. So based on the risk calculation from the historical data and the economic projections, what they needed to do with the traditional infrastructure was that had to kept raising the levee heights over and over again, and then it was really expensive to do it, and then the system itself will be like a massive and difficult to manage. So instead of raising the levee heights to deal with the increasing flooding risk, communities and the government decided to intentionally expand the flood-prone area into the nearby farmlands. So for them, by using the farmlands as a floodways and developing a subsidy for the affected farmer for the lost crop production if there is a flooding happening, and local flood management, so kind of subsidizing them when there is a failure consequences of this from the flood-prone area. They were able to redirect the urban damages to the less socially, economically vital regions and reduce the overall impact of flooding in the region. So managed consequences and expected consequences from the infrastructure design itself.
Yeah.
So I think that's a kind of good way that we can understand about how they are different. They are different approaches.
That's a really cool example, moving from a former fail-safe to safe-to-fail, but I imagine that must be pretty hard, because I think when you were saying earlier, fail-safe infrastructure tends to be very rigid.
Mm-hmm.
So making it more flexible for a wide variety of possible floods and whatnot seems like it would be a bit difficult, but I think what you just outlined here is to achieve that, you have to move beyond just the pure technological side of infrastructure, and you need to incorporate some social knowledge as well as even some ecological knowledge.
Yes, correct. So So like if you think about fail-safe approach, like one good strategy to achieve the fail-safe and robust infrastructure system is oversizing the structure
right.
itself. But to do the safe-to-fail approach, it as you said, it needs more considerations and more engagement with stakeholders in the regions, because we have to think about how might the consequences of system failure affect the region in what way and what type of impacts from it there. So here it's the sets systems approach are coming into how can we better design safe-to-fail system, and I think that engaging with like multiple stakeholders and multi-level of institution is I think really key points, and that's how the Netherlands Dutch case also was delivered to it.
Yeah, right. So can you tell us when did safe-to-fail infrastructure sort of start to gain steam as a design approach?
Sure. So while I was working on this paper, I did also literature review about what are the current studies or what are the previous studies on safe-to-fail, and then where it kind of started from. So, and then I kind of summarized the previous research in three main study areas and disciplines, and I think those three are one from urban planning, water management, and green infrastructure research area, and then second from safety science and risk analysis area, more like engineering focus, and then the third research discipline is more recent. It's moving from risk-based analysis to resilience-based analysis, so it's like coming from the resilience engineering perspective. And then if I explain a little bit about those, so this urban planning and water management and green infrastructure perspective on safe-to-fail is that it encourages and rewards innovations in low-risk context. So they're usually like small scale, and while they aiming to assess the achievements and the performance of the specific like ecosystem services, they are also looking at how they can overcome the failure situation. But in this case, failure is like experienced and learning for the future practices. So they are not really designing with the consideration of failure consequences itself, because they assume that this small-scale failure will be absorbed within the system, but they will have ecosystem benefits over that.
Yeah.
And the second kind of research area, from safety science and risk analysis, they think this area focuses on the safe-to-fail can be achieved by adding safety barriers to the system, so like increasing the redundancy of the system to contain the harm within the system boundary. So good example will be the near miss failure of the Oroville Dam. It happened in 2017. If we think about that, dam's initial function is to control flow rate of river. The dam has a secondary spillways when this function is exceeded and the river is near overflows. So in this case they use the secondary spillways and then the emergency spillways as well to deal with this overflow of the reservoir, but they did not think about the impact of ecosystem services that are disrupted by this inundation of the spillways, or they didn't think about the downstream area that will be affected by this raised water level flowing from the spillways. So in this case also, even though they safely kept the system within the boundary without the dam failure or dam disruption, but they have not thought about other consequences that might happen because of this redundancy of the system. And then more recently, these conversations between risk-based and resilience-based engineering perspective highlights that we have to strengthen the social-technical like interactions through like sensing, anticipating, adapting, and learning process, aka solve process.
Mm-hmm.
But also like this studies is limited that this study considers that unforeseeable risk can happen because of the climate change, but they also have limitations that they does not incorporate the consequences of failure in the system design and development. So these three kind of main research discipline and area are where they have thought about SafetoFail.
Okay. So what were the goals of this paper, and why do you think it's important?
So I guess the purpose of this work is to provide guidance for how to apply SafetoFail for infrastructure resilience by combining climate models, infrastructure engineering method, and decision analysis. And I think it is important because we demonstrate that how the SafetoFail decision framework can consider different resilience characteristics along with the predicted risk.
Mm-hmm.
And also we provide understandings of how the different failure modes can be happen or can be experienced in their area from the infrastructure failure. So I guess this is like kind of first attempt to apply the concept of SafetoFail into the
Gotcha.
decision making and decision support framework.
Yeah. Well, sounds important. So now just want to talk a little bit about some of the methods that you used. So could you briefly describe what the EPA's stormwater management model is and its use? I know a lot of my friends and colleagues that study flooding use this SWIM model. This is the SWIM model, correct? Mm-hmm. Yeah, so, but I've never really known exactly what it is and how it works, so I'd love to hear a little bit about it.
Sure, it's actually very straightforward simulation program. So it's developed by Environmental Protection Agency of the United States, called the Stormwater Management Model, SWIM. And it's a dynamic rainfall runoff routing simulation model that can be used for a single event or the long-term continuous events.
Yeah.
To simulate the stormwater runoff quantity and the quality from and then the kind of the intended designed target area to use this simulation is primarily urban areas.
Yeah.
So that's why it's becoming really, really kind of popular among researchers because we are all interested in calculating the runoffs in the urban area, but it's very challenging to calculate the runoffs in the urban area because there's high impervious rates.
Right. So
that's why it's one of the few programs that's available with free of cost. So the way the SWIM runs the simulation is that it uses 3 different variables related to climate and then they use these climate-related variables in hydrologic calculations. Yeah. So one thing is the primary driving force for SWIM simulation is precipitation.
Makes sense.
And then also the evaporation determines for SWIM model to calculate how quickly surfaces and soils can dry out between storm events. Yep. And the third variable is the air temperature. Yep. And this is used to model sometimes the precipitation can be from the snow melt. So they use temperature to snow melt routines and also can be used to estimate the evaporation rates. Gotcha. From the air temperature. So for this specific study of case of Phoenix roadway flooding, I used the SWIM model to simulate the rainfall runoff transformation and the runoff routing process in the main pipes of the generation network in the Phoenix urban area for about 100-year frequency storm events.
So you mentioned in this paper sort of planning and decision-making for the future and some prioritized solutions. So can you describe how your team chose those prioritized solutions?
So we wanted to look at what flooding management solutions are available to do a fail-safe design or safe-to-fail design.
Mhm.
To do that, we had to consider a suite of original characteristics that fit into safe-to-fail and fail-safe. But also at the same time, we needed to know that what flood management solutions are available across the country.
Mhm.
So we largely focused on literatures that talked about stormwater management solutions in the U.S. in different cities. So we collected about 40 different flooding management solutions, and then we kind of narrowed it down that are directly related to the roadway flooding management solutions.
Yeah.
And then each of them, we evaluated them with the 19 characteristics of resilience that can either be safe to fail or fail safe.
Mhm.
And then we categorize these different solutions with this 19 resilience characteristics to see that how might one solution feature more fail-safe characteristics of resilience or fail-safe characteristics of resilience. And then so to kind of provide some initial framing of how certain resilience characteristics fit into safe-to-fail versus fail-safe regimes, we use the multi-criteria decision analysis, MCDA, which allow us to use the multiple decision criteria to come up with solution rankings of one topic. And at the same time, we also wanted to know that how this perspective or how the concept of safe to fail can be perceived across different researchers or across different contexts of infrastructure development. So we evaluated the current researchers on safe to fail and then came up with 7 different perspectives of what researchers think about the safe to fail. And then this 7 different perspective highlights different resilience characteristics.
Yeah.
So by MCDA, using the MCDA, we could integrate these different decision criteria into one solution ranking.
Okay, so with all those methods out of the way and background out of the way, what were your major findings?
Major findings. So in current infrastructure development, the adaptive capacity of infrastructure itself is often ignored in choosing the risk management solutions. So we identified these resilience strategies that emphasizes infrastructure's various capacity, and we applied them in choosing the solutions for flooding management. So I think that's one thing that is really important. That's other than the risk calculation, we have resilience characteristics that can be considered for infrastructure design. And
so, sorry to cut you off. You mentioned a term that I'm not sure all of our listeners will be familiar with, adaptive capacity.
Yes.
Could you just briefly, in like a sentence or two, describe what adaptive capacity is?
Sure. So adaptive capacity, the objective of the adaptive capacity can be varied, but in this context, we're talking about adaptive capacity of infrastructure systems, and then I'm talking about how the infrastructure has ability to change and perform and maintain its primary intended function along the changing stressors into the system.
Yeah, so it's kind of like a metric of flexibility of an infrastructure system?
Also, flexibility and also the intended function and performance of the infrastructure system itself.
Gotcha. Sorry, continue where you were.
Yeah, so and then maybe kind of second major finding of this paper is that we confirmed that the need of new design paradigm, departing from the traditional like robust and fail-safe design. And we think that it's important that this new design paradigm rigorously considers uncertainty in climate projections and predictions during the decision-making processes and primes infrastructure to be resilient to unforeseen climate risk. And also, I think that in this way, in this context, I think the safe-to-fail approach and design strategy offers one kind of solution approach to consolidate the resilient capacity of infrastructure systems by focusing attention on the reinforcing the specific characteristics of infrastructure and in order to minimize the consequences of system failure. So I guess SafetoFail itself being an important design paradigm is a major finding.
Alright, that does sound like a major finding. So do you have future plans to build off of this work?
Sure. So actually, there are 3 different works that has been done and going on of this particular paper. So first thing is that even though we had kind of studied what SafetoFail means and what this concept actually means and how can you apply them in this paper, we also realized there is no working definition of SafetoFail.
Oh yeah.
So as a follow-up paper to that, we worked on like the new definition of SafetoFail, and also try to demonstrate like what decisions are needed and how we can address the infrastructure failure in the decision processes, like particularly focus on decision. And also, in this kind of framing and then the focus on decision process for the SafetoFail approach, we revealed like a kind of decision dilemma problem that we named infrastructure trolley problem.
Oh yeah.
Which means that the adaptive capacity of some regions might be improved at the expense of others, depending on the solutions.
Okay.
Depending on the decisions of infrastructure development decisions. So in this work, we try to demonstrate that the practical dilemmas of developing infrastructure under non-stationary climates, and like how can we guide managing trade-offs in the prioritization of different consequences of infrastructure failure.
Oh, cool.
So that's the kind of theoretical work that we are working on right now. And then
sorry to cut you off again. So with that, the infrastructure trolley problem, by the way, I love that name. That's that's a really cool name for what you're describing. So are you talking about decisions on infrastructure affecting other people and other systems spatially or like temporally? So it's a decision made now negatively affecting maybe people in the future, or a decision made now affecting like somebody down the street?
So I want to save this like a further deeper discussion on this, so you can invite me again when this paper comes out. But also I want to talk about it a little bit. So actually it's both.
Okay.
Because currently, when the infrastructure failure are dealt at the time of failure itself, so it's not usually considered in the development practices, because when you design a system, you don't want to make a system that fails. So failure is often ignored in the design. But in SafetoFail approach, we have to engage with multiple stakeholders to accommodate their preferences on like the infrastructure function and the protection level and services that they provide in their region, and also what type of kind of cost of failure, infrastructure failure consequences can be experienced by them. So then to do that, we have to make the decision on how this infrastructure might work at the time of failure in the design process. So we are making decision now for the future experience.
Right.
And then also at the same time, this decision will also affect what region, what space, or what attributes of the city will be experience more failure consequences than other, and then which population will experience more consequences than others.
Yeah.
So it has like very tricky decision dilemma.
It's cool.
Yeah. And then so to talk about 2 other studies that I'm working on.
You've been busy.
Like I recently graduated.
Congratulations.
So I had to, I had to work hard to graduate. 2 other studies that in this 2017 Climatic Change paper, we used a researcher's perspective to think about how SafetoFail can be viewed and perceived in different ways. But I think it is really important that we need to involve the real practitioners or the stakeholders in the area to determine the current adaptive capacity of the region and infrastructure system to climate risk. So we met with practitioners in the broader area of city of Phoenix. We met with the city government practitioners, and then also county level practitioners and state level practitioners, and then by using this research tool called Q methodology, we engage with them to explore what are their perspective on SafetoFail, and then how their experience and their role of institutions might affect their framing of SafetoFail, which to deal with the flood management in the Phoenix area.
Yeah.
So that's the second work that I'm working on. The third work that is more your recent idea that we work on is, since I have this role of city comprehensive working group postdoc scholar within the UX, I wanted to know that how the SafetoFail performs in different space and different contexts in different cities, and also I am also interested to identify is green infrastructure SafetoFail, because green infrastructure is a really valuable approach to design a infrastructure system to enhance the natural ecosystem value and then follow the natural cycle of to deal with the climate risk. But this green infrastructure is often conflated with SafetoFail, but I think they are different. So if you think about that the green infrastructure that is not that is designed without the consideration of infrastructure failure, I think that's still fail-safe. Maybe a common example is that small-scale rain gardens that experience ponding leading to nearby flooding. And then if it's not designed the way to manage the consequences, there are possible health impacts, ecosystem disruptions, and business disruption coming from that. So that's kind of not that's one work that I am working on right now.
Yeah, that's a cool idea. Because I think you're right in that I think people sort of assume that green infrastructure must be safe to fail inherently, but it's a good point that it might not necessarily be. We need to check our assumptions. So great, thank you so much for describing that paper, but now it's time for the ultimate challenge, which I like to ask scientists when I interview them about papers, which is to summarize your paper in the form of a haiku. So, here you go.
Okay, so I didn't know what haiku is, so I googled it, and then I found out that it's a traditional Japanese form of poems. But Stephen knows that I originally come from South Korea, and actually we have a kind of similar format of a poem called shijo. So shijo is a Korean traditional poetic form that emerged in the Goryeo periods and then flourished during the Joseon dynasty and is still written today, referenced by Wikipedia. And it also it's consisted of 3 lines, average of 16 syllables, and then it actually have a very interesting kind of structure that's it starts with introducing the situation or the theme, and then it develops in the second line, and then in the third line you have to twist it and then make a conclusion out of it.
Okay. All right.
So okay.
I love that this has now turned into a poetry lesson as well.
Yes, so I'm going to make a shijo.
Fantastic. Looking forward to it. Let's hear it.
Okay, so we have tried our best to predict climate risk. Can we ever build infrastructure that never fail? We can't predict failure. Let's keep calm and build SafetoFail.
All right. Beautiful, beautiful. That's awesome. I love that you went above and beyond what I asked. Okay, that was great. All right, that's everything that I have for you. Thank you so much, Yowan, for joining us today and sharing with us your insights and knowledge. I hope that this was informative and entertaining for people listening at home. Anything else you want to say before we go?
Thank you, Stephen. It was a pleasure to talk with you. Also, the opportunity that I can talk and about my research and share it with other people. And if the audience's listeners have any questions about my paper and current research or about Shijo, please contact me through my email, yowon.kim@asu.edu. It's YEOWONKIM.
Perfect.
Thank you.
All right. Thanks so much for listening, and we'll see you next time. The Future Cities podcast is an outreach effort brought to you by the Urban Resilience to Extremes Sustainability Research Network, or UREX as we usually refer to it. To learn more about UREX, visit www.sustainability.asu.edu/urban resilience. If you have any questions, feedback, or suggestions for future episodes, you can email us at futurecitiespodcast@gmail.com or find us on Twitter at FutureCitiesPod. If you enjoyed the episode, please rate and subscribe to us wherever you get your podcasts. See you next time.